Dr. Chuck, the science schmuck. So, I'm going to throw some more of this stuff in. I'm going to need to refill that. The next thing I want to add is carbon. Now, you say to yourself, but isn't that carbon? Like, you just did carbon. I made carbon out of milk. When you burn milk, aside from smelling like fish for a reason I cannot comprehend, it's sticky. Really sticky. Really gross. This shouldn't do that. This is just, black carbon. It's fine. It doesn't melt, it doesn't burn, it won't undergo any chemical changes. It does burn. Oh, forgot about that. Do note that carbon is flammable. That if you were to actually, like this, you could throw this around the room all you want. You'll just get copper poisoning. Milk, charcoal powder, don't stir those up. You know what a dust explosion is? It's when dust gets in the air and explodes. That sounds cool. Wouldn't that make a cool video? It would, but I don't like exploding. At all. Ooh, we're getting too hot. So, smells like nothing. I'm going to be careful to add that because, again, flammable. Should probably be wearing gloves. As you can see, I spilled some on the burner and it immediately burned, as the name would imply. However, it doesn't appear to be reacting especially much with the cooking amber. It's not amber. One advantage of carbon is that I believe it will add a secondary structure that the material can bind to and produce a better effect. What do I mean by better effect? I mean it'll be more thoroughly attached. Sturdier, so to speak. Also, carbon is highly hydrophobic, so it dissolves super nicely, like butter. Actually, butter would dissolve pretty nicely too, because it's also hydrophobic. Grab onto this without napalming myself. And pour that steaming hot goodness into the crucible. And quench this. Again, not water, but water-based, so it works okay. Okay, I don't think it's smoke. I think it's vaporizing volatiles from the material, and it's kind of smelly. Oh, I mean, it doesn't have a smell exactly, it's just sort of corroding my throat. Ugh. Well, one more thing that I'd like to try. This blue stuff, whatever it is, I want to try adding that to one. So let me go get some more of it. Well, I am back, and I'm running out of time, because this stuff is actually releasing some pretty corrosive gas. You can't see it, but my throat hurts kind of unpleasantly. It's all scratchy, and the more I breathe, the worse it's getting. So I have time for one more of these. I think that's about how much you'll find interesting as well. One more. Throw in my stuff. There is residual carbon from the charcoal. Ooh, no. One got under. Let me just get you out of there. Not in the hole. Not in the hole. It's like the opposite of golf. Let me turn that off. And hopefully not get the bolts. Okay, got it out. Ooh, that was close. So, now if you recall from the electrolysis experiment, the blue. I don't know what the blue is to say exactly. So I was trying to manufacture this, which is copper carbonate, which we just used in this one here. Blue happened when I took the effluent of filtering the copper carbonate and boiled it, and this precipitated from solution. I don't know what it is, aside from a pale blue color. It's copper-based, that's what the blue is, and there's probably a large amount of magnesium because that's the media that was used to produce this. It was produced by electrolysis of copper through magnesium sulfate, with the thought that I would then have copper sulfate, which I could convert to copper carbonate. Short summary and spoiler alert for that video, that's not how chemistry works. Ooh, we're cooking. You notice the resulting material is actually black. There's too much carbon, so this isn't going to be helpful in any way, because it's just going to be black because of all the charcoal in it. Well, radio. As you can see, the smoke is coming out of it, and I don't think it's smoke. I think it's volatilized organics, and it is very unpleasant. It's burning my lungs, burning my throat. I don't know if I've covered that or not. I don't know. There was an error where there's a lot of carbon in here. Just to modify that slightly, I want to try doing a carbon with linseed oil. Just to see how it turns out, if it's different in any way. This might explode. Remember, flammable and smoking. So we're playing with fire, not metaphorically. At this point, stir it up, mix it in. For the resulting napalm-like solution into a container. It's weirdly water-like, and it looks very much like black water, but it's not water. It's a lot hotter than water, and it's very sticky. So don't get any on you. I need another crucible. Or mold. I guess these are technically molds. That's the crucible. Oh, forget my terminology of a guy who, is quite literally a schmuck. It's in my name. Now I'm going to rinse this out, and then we can try the blue. One more before I get so sick in my lungs I can't continue. Last of what I have in my bowl. I believe I've washed out all of the carbon. There's a trace amount of water now, though, which is going to make this a little interesting. I have to try not to spill any of this on me. Heat it up and stir it down. Ew, it doesn't smell good. Alright, I'm going to add a little bit of the blue and see what that does. It's not fully melted yet, so we're adding prior to the melt. This stuff should be pretty alkaline. So I think there's going to be a little bit of a low-level chemical reaction, but I mean, I'm seeing wisps of something. And a lot of fizzing. I don't know what fizzing means. Is it good? Is it bad? I think this... Oh, yeah, we're getting a reaction. Good thing I'm wearing goggles and a lab coat. Yeah, there's a chemical reaction there. Probably because this is very heavily magnesium hydroxide and a lot of carbonates. So, lets me lower the temperatures and add more. Because if you're having a reaction, well, I've got to continue that, don't I? See what I'm doing? Is this something anyone's ever done before? Probably. Probably people a lot smarter than me have done this and realized it's not worthwhile. But they're too smart to know what's worthwhile because they have big brains that have to be filled with lots of fancy things, whereas my brain is very tiny and it can be filled with very small amounts of amusement. I don't know what's going on. The solution is brown, not blue. Not much to look at. Needs more, I guess. I don't know what it's doing. Like, what is it turning into? What is it trying to turn into? It's always a question. That's one of the things that intrigues me about this type of science, that when you're doing stuff like in real science with real chemistry, so much is known that it's like, well, Yeah, if you mix this, it's not a question of what's going to come out. It's going to be, well, is the group in the ortho or para position? And it's like, well, both, but then there's going to be a yield, and it's just calculations. With this, it's like, well, yeah, there is probably chemistry, but since nobody really does this that often, we don't know what it is. So let me move that. Oh, that is still liquid. This one is not. Got a crucible in position. Well, again, not a crucible. Ooh, looks like there's a chunk. Let me just mix that up. The gas is really getting to me. This now probably has copper in it, which is not exactly what you want to be breathing. I'm going to cut off all power because I don't have the lungs to do this anymore for today. The resulting solution looks like vomit. And quench. Okay. I've got enough air to finish this section of the video because there will be one more section. Which, after the air has vented and I'm able to breathe again, I'm going to pull these completely out of their molds and I'm going to go over what each one is, what it looks like. That one's still foaming and bubbling. And what value these may potentially have. So, I need to get to fresh air. It's just going to look to you like we just moved to that, but it's probably going to be a while. The ones that don't have linseed oil I can put in the freezer. That should freeze them solid enough that I can get the foil off. The other ones have to wait until polymerization occurs, which could take a long time. Yes. It's on the wrong side. But it's fine. It's fine. I don't know who put it there. I know exactly who put it there. I put it there. The amber. That's not actually amber. Synthetic amber. I've got a box of it. It's been sitting for about 2 weeks, drying, polymerizing, doing whatever it's apt to do. So now I'm going to go through it and see the results. Let's see, the first one here is plant resin combined with milk. Flexible, tacky, sort of gross smelling, kind of fishy. Not successful. That's a failure. For the moment. I mean, there's linseed oil in there, so maybe in a year, 10 years, 100 years, it'll solidify. Don't know how long that'll take. This is the same material that I put on a paper towel. It actually looks, this is actually still sticky. Okay, I was going to say, oh, it looks great. It works. It doesn't. It's sticky. I've got carbon plus linseed oil. Again, flexible, sticky, not working. I think the linseed oil polymerization thing either takes a very long time or doesn't really work well. Well, then again, we do have this. These are fragments of the piece that was just tree resin and linseed oil. You can see it's assumed this very pleasant dark color, and it's very brittle and sour. I'd actually say that that is an okay success. It's about the same consistency as tree sap, so that's fine. Like, that will work for a lot of applications. I definitely say it's not amber, but it's sort of, you know, valid. Carbon and linseed, again, it's too flexible. Oh, it's on me. No, I'm sticky. Well, I'm always sticky, so I guess it's not that big of a deal. I'd like to be able to spend part of my life at least not being extremely sticky, but I'm sticky, sticky man. Carbon without linseed oil. Again, without the linseed oil. Listen to that. It's black, glass-like, light, relatively hard, mostly tasteless. That's a resounding success. That's black colored tree sap. I mean, it's not successfully amber, but that is a substance that can be used to make things. things that are similar in consistency to glass but made out of organic material. Moldable, you could melt this down and mold it into something. For example, a handle on a nice knife. That might be, I don't know if this is before or after the epoxy knife. That one doesn't have a handle because it's inbuilt, but I am looking toward making some other knives, actually out of steel this time, and I need a handle substance. This would be a very valid handle substance. It's sturdy, it's relatively hard, it's light, it's pleasant to touch. What else have I got in here? This is made from the blue stuff. Again, not sticky. It's same consistency as that, except it's green, which is weird because the stuff I put in it was blue. Slightly brittle around the edges, but yes, I can split it. It actually looks pretty nice through the middle, but you do see at the bottom all the heavier pieces sunk down there. It's still cracking somehow. It's sort of glassy. I'd characterize this as glassy. Again, a substance that could be used for a handle. Also, because of this, I think this could be polished into something more gem-like. And finally, I think this one came out pretty well. This is the copper carbonate combined with the material. That is actually a pretty pleasant green color. The back side is bluish, and that's where fragments have sunk. But the surface actually has this interesting modeling pattern because when you combine it and it hardens, it has convection current. So parts of the material come up to the top and it flows, and that's not bad. Like I could, file down the ends and affix this to something as a gemstone. It's not a stone. But that's pretty good. Now, again, these are mostly prototypes. What will I use them for? Why am I a sticky man? Oh well, without answering that question, one of the things that I wanted to do with these is make artificial gemstones, which, looking at the density of it, maybe not the best material for it. It's not really quite amber. It's durable and heavy and resistant to water, and you probably could shape it. But amber is a very different substance. There's mineralization. It's that millions of years old that it's been going through these processes. For all I know, these, by the time there are dinosaurs wandering around the earth again, will be hard. And some dinosaur man will dig this up and say, there's been a schmuck here, and I think he was sticky. Regardless, I think that if I put these materials in a polisher, like a rock tumbler, I probably could get some interesting results, but that's a little bit beyond the scope of this video. I think I will be doing a separate video on polishing various materials in a rock tumbler to see if I can get anything that's shiny without having to spend any money. For now, I don't know if this will even be... Why am I dusty? And sticky. How can I be both? I don't know if this material will be of any interest to the viewing audience, but then again, I don't have a viewing audience, so it doesn't really matter. It is of an interest to me because it establishes, again, that these materials can be used for either gemstone applications for producing small, amber-like gemstones, but also parts, pieces of material made out of organic matter from trees, renewable resource, that behaves like corn or plastic while being entirely vegan. I think. The milk one's not vegan because milk comes from a chicken. So that actually, I think for now, concludes this. If I have any developments with getting harder, I'll let you know. These will also probably come back in the future, or materials like this will come back in the future. So keep watching to see that. You don't need to like and subscribe, it doesn't matter, but I do appreciate comments. So if you have any ideas that are better than this, or even worse than this was an okay idea, let me know and I'll see if I can scientate them. And with that,